Good evening, everyone. And okay, so this is your second lecture of ray optics. In this particular lecture, what we are going to discuss, mainly importantly, two kind of thing: TIR, or you can say Snell's law. Okay, so Snell's law and TIR, both the things you already know, but in the advancement and you can say a little bit in detail, we are going to discuss this particular two concept in general mainly. Clear, everyone? And both of them are important, and in this particular mirror, or you can say on refraction pattern, or in on refraction part, if you are going to face a question, so specifically basically on critical angle, basically based on TIR, total internal reflection, and Snell's law refraction, which is you can say RI, refractive index, for continuously 2 to 3 system, or continuously 2 to 3 slab, or you can say medium, which is going to be passes on. Okay, so as we everyone know what a refraction is, whenever a incident light ray, or you can say whenever a light ray is passes from one medium to another medium, so it going to bend due to the you can say different mediums. So one medium, sir, I will on my video in 5 minutes. Okay, so as we know, medium one is you can say the rarer medium, RARE, or you can say air, and the second medium is basically the denser medium, or here we can say that glass or water. Okay, let's take a water. So whenever this particular concept, I mean whenever this particular phenomenon is going to be simply when the light ray or ray of light, when the light ray passes from one medium to another medium, from one medium to another medium, from one medium to another medium, it deviates its path. It deviates or changes its path. It deviates its path, and this particular phenomenon is known as is this clear now? And this phenomenon is known as refraction. This particular thing we take as a perpendicular line, as a normal, to make sure how much the deviation is going on. In general, what is going to be, if there is a not change of the medium, so the light ray in general is necessarily going to pass in this way. But this slight deviation is going to be because of this particular process known as refraction. Clear, everyone? Denser medium is a kind of a medium in which the ray of light is not going to be the same as a speed of light is going to be minimum or lesser than the speed of light in air, where speed of light in vacuum or air is c, which is going to be 3 into 10 to the power 8 meter per second. In general, in any other particular medium, it is going to be lesser than that. V equals to c by mu sometimes, or V equals to c by n, where mu and n is going to be RI. RI stands for refractive index. Is this clear? Or should I tell you something more about it? Diffraction. Clear, everyone? Basically, each and every particular thing is given already, but still we need to discuss it. Clear? Mu and RI. More than that, you can understand denser is a particular in which light ray is going to be lesser as compared to the air. Denser means dense enough. Okay, so one basic example you can correlate, or you can make it an analogy. Whenever you traveling or riding a bike on a particular highway, clear, or you can say newly built road, so your bike or your motor, or you can say your four-wheeler or two-wheeler is going to be run very fast. But the moment you are going to change the path, or you are going to choose a particular path which is not that much newly built or not clear, or you can say a state road or a village road, so automatically you need to change your speed, because if you don't, so you're going to be fall maybe, and then maybe the accident is going to be happen. So what is that? the moment we change the medium. Clear? So due to that particular denser medium, the ray of light is going to be lesser, or the speed of light in general is going to be changed. And we know in the previous classes, or you can say basically in the EM wave, we know this thing clearly. Speed of light is what? Lambda into f. Remember? Or you understand in this way? So in refraction, I can give you a note here. In refraction, in refraction, speed of light, speed of light, which is c or v, is changed, or you can say is going to change because of change in wavelength, which is lambda, where the main thing I am writing right now, where frequency is constant. Okay, is this clear? And why it is going to be constant? Because frequency is a frequency is going to be 1 upon time period. So we say that speed of light c is going to be changed because of change in lambda. Clear? So there is one MCQ one. If there is a change in, or you can say in refraction process, whenever a light ray is passes from one medium to another medium, or you can say rarer to the denser, or denser to the rarer, so what one thing can change? Okay, frequency, lambda both, lambda only, or frequency only, and all of the above. So you need to pick lambda only, because both cannot be changed simultaneously. Clear? And speed of light change, so automatically either frequency is going to be changed, either lambda. So lambda is going to be changed here. Moving ahead, now what I already given to you guys, that is written in the proper words. So what is refraction? The bending of a light wave when it passes from one medium to another due to the change in the speed of light traveling with the two different media is called the refraction of light. Is this clear, everyone? So this particular diagram image is basically the or you can say ray. I don't know why. Just a minute. Okay, so this is basically again your refraction. As we can see here, whenever a light ray, that is your incident light ray, okay, it is going to change, or it is going to enter in medium 2, which is denser, or you can say any particular. It can be denser, it can be rarer. What is a rarer or denser medium? Do you guys remember? Because that already we teach in class 10. Do you know what a rarer medium, what a denser medium? Everyone. Sudarshan, Shrutika, Vishwanath, Yajira, Pavan, Aditya, everyone know na what is a rarer or denser? And Parikshit also. Parikshit know everyone about it? Yes, sir. Okay. Rarer medium in which speed of light is more. Rarer light ray bends away from the normal. Means if the incident light is coming from denser medium away from the normal and going into the denser rarer medium, so it is going to bend away, and in denser it is going to be vice versa. Vice versa means reverse. In denser light ray, or you can say incident light ray bends towards, as you can see, whenever a, okay, let me write it down, towards the normal. Okay, so as you can see, it is going to be bent towards the normal. If it is going in a reverse way, means if you can think it is a denser medium and it is a rarer medium, so it is going to be bent in this way, away from the normal. But in this particular case, in this particular scenario, where what we can see that a band of light ray is going to be towards the normal. But in reverse case, it is going to be far. Or in general, what I can make for you, here suppose this is the normal again, okay, and now the incident light is directly coming on this particular suppose there is a bulb over there, and then the light is coming in this way. So instead of going directly, it is going to be bent. If the light ray is going to be coming this way, so instead of going directly, the light ray is going to be bent a little more away in this way. Clear? And automatically, as we have angle of incidence, so same here, as we have angle of incidence, and instead of reflection, we have an angle of refraction. So everything that is already done in the previous classes. So if you don't know, so let me know. So now important terminology, that is normal, incidence, incident ray, refracted ray, everything. Just a revision kind of stuff. Let's do this also. Normal, the point on the surface at which an optical phenomena occurs, is called the normal. In simple word, the term, it is termed as the point of incidence. It is shown by the dotted line perpendicular to the surface of a refracting material in a ray diagram, or you can say at particular point where we are going to observe the particular concept or phenomenon of refraction, or a particular point which is perpendicular to the surface, or no, you can say where we draw a perpendicular or a normal to the surface to find the angle of incidence and angle of refraction, that is known as normal. Incident ray, everyone know, the light ray that strikes the surface, refracting surface at the separation of two media is called the incident ray. Refracted ray, the light ray that bends after passing into the another medium, is called refracted ray. Is this clear, everyone? Either it is going to be bent near towards, or either it is going to be bent away. Moving ahead, angle of incidence, angle of refraction, that is important, going to be used in Snell's law. So you need to understand angle of incidence, what it is. This is the angle between the incident ray and the normal, that is represented by angle I and angle R, nothing more than that, the terminology. Now use of refraction. So that is again the uses of refraction based what we already done. The stars twinkling in the night sky due to the refraction of their light, first important use. So as we can see, or as we learn in the PG classes or early ages poem, twinkle twinkle little star. So star is not going to twinkle, but because of atmospheric refraction, we seems that, and it is going to be seen that it is going to be twinkle. Clear? Because the intensity of a light due to this air refraction or atmospheric refraction is going to be changed throughout the time. So it is feeling like that is going to be twinkle, but star it is not. Okay, looming and mirage formation, that we are going to understand what it is. Both occur due to the optical illusion caused by the refraction of light. The formation of rainbow, whenever there is a, you can see the rainbow. So what is a rainbow in general? Rainbow is the splitting of white light into its 7 color components, or you can say due to the refraction. There are two types of refraction: internal reflection and atmospheric reflection. So when a light ray passes from air to the water, so it breaks into its 7 color component, and the dispersion process is going to be done. But in general, what is the process is going on there? Refraction. Okay, the formation of rainbow in the sky and vibgyor when the white light passes through the prism are also major example of refraction. A swimming pool always seems or looks much shallower than it really is because of the light that comes from the bottom of the pool bends at the surface due to the refraction of light. Okay, so the height of the pool you cannot measure actually or whatever the height of a pool or any particular object inside a water is looking a little bit extra in size, because the light ray coming from that particular denser medium, which is a water, in air is going to be bent away, so that particular object looks big. Clear? So that is the process. Laws of refraction. Now that is important, as we have two laws of reflection. What are those? Tell me. You remember two laws of reflection? In a same analogy, we have two laws of refraction. Angle of incidence, angle of refraction, and the normal all are lying on a same plane. And sin I by sin r equals to a constant thing, that particular constant for a specific media. And then constant is known as Ri, refractive index of that particular two media altogether. Is this clear? But before that, tell me what is the law of two laws of reflection. So the second law of reflection, I am talking right now for reflection. For reflection. For reflection, the first law is angle of incidence equals to angle of reflection. Okay, and the second is angle I, angle R, or normal to the perpendicular, all lie in same plane. What is the meaning of that? Please anyone tell me the second line or the first law of refraction, if you know, anyone. Angle I equals to angle R. Yeah, beta, we know this. I'm asking the reflected incident and the normal at the point of incidence, all will lie to in the same plane. What it is in general. This is your first law of refraction, and that is your second law of refraction. So what your all lie on the mirror. But I write same plane instead of mirror. What is the meaning of this? Tell me, beta, what is the meaning of this plane thing? I don't write neither the mirror, neither the surface. I write this plane thing. Tell me, from this diagram, tell me please everyone or anyone, what do you guys understand from a plane? I don't know how many times I already given to you guys the definition of a plane. Plane is nothing but the area covered by two axes. Clear everyone? Is this clear? What is plane in general? Plane is nothing but, this is your x-axis, this is your y-axis. So this is your plane. So in this case scenario also, if I make the same thing, okay, suppose I make this. This is your one axis, this is your another axis. So this is the plane, this whole thing, this is a plane. Or more simplistically, I can do that also. More simply, I can do that also. This is your plane. This is now my origin. Sorry. This is the origin. So angle of incidence, angle of reflection or refraction, and this perpendicular all lie in a same plane, isn't it? The area, the region covered by two axes, that is plane. Clear everyone? So that is the meaning of this thing. Is this clear everyone? Clear the first law? Okay. Second law states that in the refraction process for a specific media, or you can say for a fixed media. Media means for fixed medium. Not media, that particular media. Or you can say the fourth pillar of democracy, not that. Okay, not television media. Media means medium here. Secondly, the ratio, or you can say second law states that the ratio of the sine of angle to the incidence and refraction is constant, and that is termed as Snell's law. That is important. Because of that, we can prove so many things. Okay. So sin I by sin R, it is a constant n, and I cannot give you the theoretically proof of that because it is experimentally proven. Whenever we fix sine of angle of incidence to the sine of angle of refraction for a fixed medium, what is important note here, for a fixed medium, you cannot say that like it is going to be constant from air to water to air to glass. Air to glass something else, air to water something else. Clear? And that constant is basically Ri. So simply second law, or you can say Snell's law state that simply sin I divided by sin R, sometimes it is written over mu, sometimes is n, and sometimes uh, mhm. What is the meaning of this? Refractive index of 2 divided by refractive index. Okay, write down this thing and then sin I by sin R also 2 nu 1, which is nu 2 over nu 1. What is this? Instead of air to particular medium, if we have another medium, for example, uh, here medium 1 can be the water. Clear? Suppose here the medium 1 I can put a water. I can put you can say LED or a bulb inside a water, and then due to this particular LED or bulb, suppose this is your LED or bulb, and due to this LED or bulb there is a light source. Okay, so incident light is going to be from water itself. This is your water and this is your glass. So both are the denser medium, and that is your air in this way. So what is that is the meaning of mu 2 over mu 1, which is refractive index of 2. 2 means the second medium. Always consider that the medium that is going to be much confusion when we going to talk about 3 medium, 4 medium. Okay. So only even in 3 medium you are going to confuse, even maximum students going to be. So the whatever particular medium we are going to take the upper thing, or you can say the refractive index, is the medium in which the light ray is going on. And if it is simply going from air to any particular medium, then simply nu, and that is nu is nothing but c by n. What it is speed of light in air. Again you can see that n is basically the refractive index. Okay, I can wait, that is not correct. Yeah, that is correct, v. So if I find n from this, or you can say nu refractive index, so that is c by v, the speed of light in first medium to the speed of light in second medium, and that's nu and n is basically the Ri refractive index of, because Ri n or nu equals to 1, almost 1.001, which is not. Okay, is this clear everyone? So whenever we doing in this scenario, in this case, like sin I by sin R, nu 2 by nu 1, that is the meaning we don't have the first medium is air. Okay, you can say that two different medium, you can say, other than air, other than air system, air or vacuum. Clear? Is this clear everyone? So means simply if the light ray is passing from air to any particular medium, so simply mu or n refractive index, that is the speed of light uh, in a air divided by the speed of light in this particular any other medium. If it is going from you can say water to glass, glass to water, water to kerosene oil, or any particular other media, water to diamond maybe, so then it is going to be in this way. Clear everyone? Good. Done. Done. So what is refractive index? What whatever I explained to you in the previous page, that is written over here. The refractive index is also called the index of refraction, enable us to know how fast light travels through the material medium. Or in general, you can say that refractive index is the index of refraction, which enables us to tell how the refracted ray is going to be bent. I don't care whatever the bending way is, either the away from the normal or either the towards the normal. I am interested in how much it is going to be bent. Clear? So this N, which is C by V, is basically given you how much your speed of light is going to be changed, and on behalf of this speed, your wait a minute. On behalf of this particular speed of light, you can say that and you can tell that how much it is going to be bent. Is this clear? So that is important thing. Clear now? Clear with everyone? Important also. And we see that V is the speed of light in medium, C is the speed of light in vacuum. The given velocities of light in different media again this medium, can give the refractive index. So N21, clearly understand this, either you can write this or either you can write this. Whatever the first subscript there, that is the medium 2 or velocity in medium 2. Clear? As you can see from here, that is nothing but speed of light in medium 1 to the speed of light in medium 2. And what it is? Refractive index of medium 1 to the 2. Clear? Where N21 is the refractive index of 2 with respect to 1. Means we are interested to find the refractive index only and only in that particular medium in which the light ray is going. Clear? We are not interested, and rather we are taking care from which particular medium the light ray is going. We are interested in which the light ray after the bending, after the refraction process is going on. Clear? Good. Because that one confusion can alter your answer. Okay? So that is important. Now, sin I by sin R equals to constant, that is N. It is important, we have already done that. Second law. Where sin I by sin R is V1 by V2, N2 by N1, where I and R, the angle of incidence and refraction, N is the refractive index, and N1 and N2 are the refractive indices of medium 1 and 2. V1 and V2 are the speed of light in medium 1 and 2 respectively. Go ahead. That much lag. Moving ahead. Rarer and denser medium. A rarer medium or optically rarer medium is a medium in which the speed of light is more. For example, air is optically rarer medium as compared to the glass and water. So important for the definition part. Denser medium or optically denser medium in which the speed of light is less. For example, glass is optically denser medium as compared to air. Clear? Good. Now types of refraction. See, I can run on this because you guys know these definitions, and I hope you know these definitions, because the main thing we need to focus. So types of refraction. The refraction of light occurs in different ways depending on the medium through which the light travels. Refraction from denser to rarer medium or refraction from rare to denser medium. So that is two types you can focus it on. Simply, whenever a light ray is going from rarer to denser, simply light is going to bend towards the normal. In a reverse case, vice versa. Whenever a light ray is going to be from denser to rarer medium, optically rarer medium, so simply the light ray is going to be away from the normal. As simple as that. So that is your D to R, denser to rarer, and that is R to D, rarer to denser. Clear? Good. Some important characteristics of refractions. Let's focus it out. Even I told you this one. That is important one. You can note it down. What it is? The frequency of light does not change when it travels from one medium to another, but the velocity and wavelength of light changes. The second one, a ray of light bends when it travels from one optical medium to another with a variable refractive indices or index for a specific pair of media, the ratio of sine of angle to the sine of angle of incidence to the sine of angle of reflection is constant. That is, means for a pair of media, n is going to be constant, mu is going to be constant, Ri is going to be constant. The relationship between the medium refractive indexes and the speed of light is that. That medium is follow. I'm running like a bullet train today. I don't know why. I think it is so easy for you and for me to teach in both the senses. So I can do that at least, right? Because this thing already you guys know in class 10. Whatever the main thing is going to be there in coming slides, obviously. So then I am going to focus. Right now, let me run as much as I can. Because what happens since last 2-3 class, I start explaining everything, and then the main thing is going to be remain. Lateral shift, everyone know, and if you don't, so let's do this thing. What is a lateral shift? As we simply know, if there is a no other medium, you can say glass slab or you can say a water, so the light ray is going to be passes directly, as we talk about in this way. So the shift, okay, or you can say the shift in the light ray due to this refraction process is known as lateral shift, nothing more than that. A ray of light travels in a certain straight line path. After refraction through a glass slab, it emerges in a direction parallel to the original direction, but slightly displaced from the initial line, from the line. This is called lateral displacement and lateral shift. This d distance is in general a lateral displacement, or you can say lateral shift. This one, as you can see. Okay, this is your lateral shift. Clear, everyone? That is air, that is glass slab. Refractive index mu1, refractive index mu2, I, R1, I2, R2. Nothing more. So what it is, we are going to find. Okay. Okay, let me see. There is a also no. You don't need to necessarily because see to yes, to give you this particular everything, I need to tell you so much of geometry, trigonometry, and so on. So I don't want to. Neither it is necessary. Refractive index and thickness of a glass slab is mu and t, means if refractive index of a glass is mu and the thickness is t, one light ray AB incident on a slab, displacement produced it in emergent ray due to refraction. So that x, which is a lateral shift, x is p sin I by sin r divided by cos r. And how you can find it down? I can have that in my mind. Sin I by r. If should I need to give it to you? See, there is tan of angle of theta, any particular theta, which is x upon t, and that is sin r prime divided by cos r. So there r prime is I minus r. That I can think from this definition at least. Okay, and if it is I, this is r, and that angle vertical opposite, that is r also. And how can I do after this? Okay, just look at it. But the main thing is we just take care of two angles which are equal in this way. Okay, you don't need this, but still if you want to, so you can let me know in the next lecture. I can provide you. Right now even I don't know the actual proof of that, but somehow in this way we can prove that. This is the most important thing in this lecture, or you can say very important, and we are going to talk about this in a great way. So as we know, the refraction going to give us a change, or whenever we put any particular object, so it seems a bigger, or the height or the actual height is not going to be the, I mean the height of a swimming pool or the height of that particular any water body is we seems like lesser as to the actual height. just because of this refraction process. So there is a real height and there is an apparent height. So apparent height is what? Apparent height, that particular height which we see, which we think like that is the actual height because of refraction process. Clear? So the apparent height or the apparent depth is the distance of virtual image I from the surface of water. In general, what is happening over there? Suppose any particular object is situated over here. So this is the real height of this. But due to this refraction process, that object we seems here in simple. Clear? And how can I tell you? Suppose this is your object, but due to refraction, whenever the light ray is coming, whenever the light ray is going on, so it is going to bend towards the normal. Suppose instead of this, the light, incident light is coming from a bulb, which is going to help you out to which is going to help you out to okay, and this is another. So as you can see, basically the object is here, but these two different lines in actual meets at this particular position, which is your image. Clear? So what happen in general, suppose there is a light coming from any particular source in this way. So the actual object is here. This is your object. But you see that particular object here, and whenever it is going to be so from this particular object, even if you are doing the reverse case, if this is any particular object which is luminous itself, so for luminous object there is a one light and that is going to be a little bit bent away, and there is another light source. I can make a normal here. Just a minute. Not this color, this color, this color. This is just another normal. Okay. Again from this normal, the light ray is going to be bent and it is going to into the eye of a viewer. So the actual light is coming from this, but due to this refraction process, this is going to be visualized. I need to choose different color to make it visible, and this, yeah, that is the actual refraction. Clear? Because this particular observer think the object is here instead of this particular position A to B, and there is a difference in height that is known as apparent height. Clear, everyone? You can do this small activity just by taking care of take a small coin, put it in that particular coin in a bucket, so that when you try to pick that particular coin by your hand into the bucket, so you automatically feel that from the upper hand, from the air, the height of the water and the coin, it seems like it is going to be just till height. But the moment you are going to catch that particular coin, your whole hand is going to be into the bucket. Okay, that is a natural optical illusion, and that is why we are learning this. Because of this optical illusion, we need to calculate, we need to find the actual height, because whatever we are seeing from the air, from the, you can say, ground surface, that is not the real thing. So due to this, so many incident in the sea, or whenever you can say the big fisherman is going to trying to put a net to catch the fires, they are not going a single fish because of this thing. So we need to find the real height. Okay, so the real height is the distance of the real object O from the surface of the water. From the surface of the water we are talking. So this is the real height. Suppose this is, you can say the real height is 10 meter, but the apparent height we can see only 6 meter. So the relation between the relation of refractive index n to the real depth to the apparent depth is this. Okay, so n, which is refractive index, is nothing but real depth divided by apparent depth. AD is apparent. Apparent means which is going to appear, not in actual. And that is how we can find. Okay, so now this is the relation when an object is in denser medium. So real depth and apparent depth, it is going to be give you the relation only and only when an object is in the denser medium. Obviously, if it is in the rarer medium, an object, so that is not any particular problem. So thickness of a denser medium, suppose this is the thickness of a denser medium T, in which an object is at particular position O. Okay, due to the refraction, image may be seen at particular point I. You can see in this way also, as you can see, okay, from this, like if it is the I, so from this diagram you can understand in a great detail, light ray is going in this way and it is going to be bent away. Clear? In a same sense, light ray is going to be in this way and it is going to be bent away. So how you can see that object? Virtual rays. Don't worry about it. So this two virtual rays in your eyes is going to give this kind of image. Okay, bending can be done in any other direction also. No? It is not necessarily written it is going to away in this direction only. It can be in this, it can be in this. So that is how, instead of this, we can see now if this is going to be, or if it is incident ray, so this is your object look like at this particular height, and that is I, that is O. Okay, so if you know the thickness of a slab or any particular denser medium and you know the refractive index, so the refractive index mu or n, real depth upon virtual depth, or you can say real depth upon apparent depth. Real depth is AO, apparent depth is I, where AO is T and I, and this AI is AI. So virtual depth is T upon nu. Okay, T upon nu, where virtual displacement is OI, how much it is going to be displaced. The virtual depth is AI, where the virtual displacement is OI. OI is OA, means actual length minus apparent length, or actual height minus apparent height. So that is T1 minus 1 upon mu, and that is important. So what it is? Shift, or what this particular thing is? Shift in apparent height, or shift due to apparent height, or due to apparent shift due to apparent depth, and what it is? X again, yeah, that is T1 minus 1 upon mu, where mu is actual depth, or you can say real depth, divided by apparent depth. Clear, beta? So this is important, both the things, this particular formula or this particular formula, both. Important. Clear, everyone? Where sometimes my brain works so much fast that my even hand cannot coordinate with that. It happens when you know any particular thing in a great detail, so your mind works that much you can say fast enough, so you cannot able to write, and that is why the writing or handwriting of a doctor is very bizarre. Only pharmacist can learn and understand what they are written, because they are so much busy, and they in their head there so much thing is going on. Do you know how much a doctor is working per day on an average? On an average, do you know anyone? If you have anyone, your elder brother or father or anyone, 10 hours, not more than that. At least 13 to 14. At least I'm saying. Because on an average, any particular MBBS doctor from renowned hospital taking any one or two classes in any college for the final year students, then going for a round two times to check up and to see his or her parents, and then a surgery, and then at least surgery took 3 to 4 hours. So 3 to 4 hours surgery, then 2 rounds at least 1.5 hour, 3 hour, and then 1 hour classes. So two. So how much? 4 and 3 7, and then 2 9, and then here and there and file work also. At least 12 to 13 hours. I mean at least more than 10 hours, what I know in general. Okay. So that much hard work they are doing. And in any particular specific cases, like if sometimes or many times happens with the government doctors, whenever they are going to leave to their quarters or to their rooms, any particular emergency is going to be an emergency or an emergent surgery, and that surgery took another 2 to 3 hours, or maybe more than that. 2 to 3 is a minimum bear time. Minimum. Sometimes it is going to be 4 or 5. Clear? So, whenever you need to face any doctor in future, just praise them. They are going to be happy. Okay, that is shift due to apparent depth. Important everything. So again, this is if we have a more than 2 medium. Okay, and if this T1, T2, T3 are the 3 heights. So simply the same formula we are going to use. Refraction through successive slab of different thickness and refractive indices. Virtual depth AI. This is your virtual depth now. Okay. T1 upon nu1, T2 upon nu2, T3 upon nu3, and that is going to be n number of times. So the virtual displacement. Okay, the previous word is as you can say shift due to apparent depth or virtual displacement also. So the virtual displacement or shift due to this refraction process in the apparent depth in the real depth is OI. That is your shift now. Instead of this particular point, you are seeing this. So how much is the shift is going on? This much shift is there. This much is the shift. So you can see virtual shift. Sorry, virtual displacement, or the word itself describe it. It is not going to be displaced, but we see over there. I mean, we are going to see over here. So virtually it is going to displace. So that is why virtual displacement. Clear? OI. This is your I, and this is your object OI. T1 upon T1 1 minus 1 upon nu1, T2 1 minus 1 upon mu2, and so and so. Nothing more than that. Why so? Because for T1 it is going to be T1 minus this displacement virtual depth. For T2, T2 minus virtual depth. For T3, T3 minus virtual depth. Virtual displacement we done already. Okay. So that is important. When an object observes, you can say when object observes both are in rarer medium. If it is going both in the rarer medium, so let observer is in rarer and object is at a point O in air. As you can see in figure, a glass is there in between observer and object. Images from at I. Okay, image is going to be formed at this particular I. Point I, refractive index of glass is mu. So again, virtual displacement is going to be always and always uh, T1, T1 is missing here, 1 up by 1, T1 into 1 minus 1 by mu. Application of refraction. Wait, how much it is now? Application, and then we have a question. Good. So application of refraction of light, we already done this. So let's revise this. Refraction has many wide common application in optics and also in technology. A few of them are given below. So the first one is a lens use the refraction phenomenon from a to form an image of an object or a body for various purposes such as magnification and so on. So we are going to discuss the lens magnification and everything in the next lecture, not in this. Spectacles that are worn by people with a defective vision use the principle of refraction. Refraction is used in pinholes, or you can say in peepholes of the house doors for safety, in cameras inside the movie projectors, and also in the telescope. Okay, so this is all about the applications and uses of refraction. Then do this question. A ray of light is incident on a surface of a glass slab at an angle of 45 degree if the lateral shift produced per unit thickness, lateral shift x is given over there. Okay, and there is a relation. What is the relation of a lateral shift? I'll give you the depth. Lateral shift T sin I minus R divided by cos R. Okay, so T is there, if I'm not wrong, thickness is there, and angle of incidence is there. So you need to find the angle of refraction per unit. So this particular thing is per unit, na? So mu by T is given to you guys, if I'm not wrong. Mu by T is given, or you can say hint. What is hint over there? As we know, lateral shift y is going to be T sin I minus R sin I minus R divided by cos R. Okay, so here this y by T means lateral shift per unit thickness. Per unit thickness you need to do the 1. Cos R. I is given. Yeah. Okay. Do a little bit math. Sin A minus B, sin A cos B minus cos A sin B. And do then. Clear, beta? You need to use the formula sin A minus B, sin A cos B minus cos A sin B. Simple, and then just put it down and you can find the R. Do that quickly so we can do the next thing. And then after a break, we are going to do the main thing, TIR. Total internal refraction, reflection. Clear? Is this? Okay, do that. Everything is given to you. And then we are going to discuss one more question before break. This is very easy, student. Please do this without any assistance and help. I already given whatever the necessary thing I need to given to you guys. Right now I'm adding your this class assessment thing. Still, if you want to ask anything, please let me know. and try to be vocal more instead of typing and writing. If you want to ask something, ask me so I can hear you out. Because sometimes I think you are not able to speak. I don't want to with anyone. Take my words in a joking way. Don't get serious, anyone, please. Because right now so many things is going in your head. So don't take anything serious. Whatever I'm make a joke or fun of you guys. And sometimes mine too. I mean myself too. It's going to be done. Just a simple second. Option B. B. How many guys get option B? But I don't get option B. Option B. Option B is correct and written over here is C. Yeah. Option B is correct thing. Yes. But I got root 2 by 3 not. Root 2 sign is going to be the problem. See what happens whenever any particular SME create that thing. So the extraction team sometimes skip this sign. Okay. So lateral shift y by t, that is already I given to you, that is you guys know. Just putting down this value. So sin I by sin r, and that is sin 45 1 by root 2 cos 45 1 by root 2, and tan r is going to be 1 by root 2 1 minus tan r. So tan r is going to be 1 minus root 2, or this r is tan inverse 1 by root 2 by 3. Whole root 2 by 3 you guys get now. Okay, do that then. Clear? First of all, I need to rewrite here. Wait. Now it will be. Okay, good one. What is the value of sine of the angle of incidence if the angle of refraction is given to be sine 35? Value of refraction index 1.3. I don't think so easier than this you can get something. Find the value of sine r, which is sine 35. Okay. Anyone know what is sine 35? Mostly generally it is given in the book or in questions, but it is not given, so I can give it you. Okay. I think now you don't need to do anything. Where? So that is easy. Sin I by sin I constant. Constant is 1.33 is given already. R is this. So that is the value of sin I. Okay. So let's do this. What is TIR? TIR, that is important thing, or you can say that is the main thing in this particular lecture. TIR in general is total internal reflection. First of all, what it is, there is a specific angle known as angle of critical angle in general. So if any particular light ray is coming from, or you can see any particular source is inside a denser medium, okay, and from that particular source the light ray is having more than critical angle, so it is going to bend again into the same medium. So that particular process is known as TIR. Now, what the particular critical angle is? A critical angle is that particular angle. Suppose there is a medium. Everything is going to be written over there, but still I want to tell you. And there is a this particular thing. Again, we take a bulb over here. Suppose this is something here. Okay. So what is the critical angle, students? Critical angle is very easy to understand. Critical angle is that particular angle whenever any particular source or any particular object is in the denser medium. Suppose it is a water. So the refracted, I'm saying refracted, the refracted light ray is going to be perpendicular to the normal. Is it clear? That particular angle of incidence is known as critical angle, because this is your object in water, or you can say object in denser medium. Object in denser medium. Object in denser medium. Clear? So if any object is having in the denser medium, so that particular angle with which the refraction angle with the normal gives you 90 degree angle. This is your incident ray, this is your refraction ray. So that particular angle is what? Incidence angle. You can see critical angle. Now this particular angle is known as angle of C, critical angle. Now what is TIR then? If any particular light ray is going to be more than this angle, more than this, you can say, suppose, who is speaking here? Don't do. Hello? Hello? Who tried to speak, beta? Yeah, let me know. Yashordeep, are you? But don't do then if you are. Okay. If this is your light ray. So now in this particular case scenario, we can visualize directly this is the more than incidence. So in this particular scenario, the light going to be bent totally. The light is going to be bent again in this medium. So that is your TIR, total internal reflection. To complete reflection of a light ray at the boundary of two media, when the beam is in the medium which is at a higher refractive index. Obviously higher refractive index means this is if have a higher refractive index. So we know air or vacuum, VACW, vacuum or air have refractive index mu. I'm going to write away always 1. So the any particular refractive index which is mu medium greater than 1 or more than 1, so it is a denser medium. Clear? So in this particular scenario, that is going to be happen. Conditions when the light is approaching from the less medium, or you can say less dense medium from the dense medium, and so and so. As you can see, that is theta 1, that is theta c, or if theta 1 is going to be more than theta c. What is theta c? Theta c is the critical angle. Clear, beta, everyone? So I'm leaving you guys on this slide. There is a 5 to 10 minutes break. Okay, and after the break we are going to discuss about this. Okay, you guys also go get water. And the phenomenon in which the incident ray is greater than the critical angle is called TIR. Exactly, sir. We can also say that this definition. Yeah, you can. Oh, hello, hello. Am I audible? Hello, 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 hello. Hello, 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 hello. Okay. So, audible. So this is your TIR, total internal reflection. Okay. So conditions for TIR: when the light beams go from a optically denser medium to a less optical denser medium, that is the necessary condition. Important one. Okay, more optically dense medium from a less, go from a more optically dense material to a less optically dense medium. This phenomenon happens. There are two situations in which TIR occurs: when the light is approaching the less dense medium from the more dense medium, if the incidence angle is larger than the critical angle, and both the necessary condition, and both the conditions are necessary conditions. Okay, so this one, condition 1 or 2, both are necessary. Both are necessary conditions. Clear, everyone? So that is the picture, pictorial representation. If it is a water, if it is a air, N2, N1, it is going to be N1. It is N2. So simply, incident ray is going to be refracted, but a particular incident, you can say a particular incident angle is known as angle, critical angle, where the refracted ray, as we already discussed, as I already let you know, is going to make a perpendicular angle with the refracted. Either you can in this way make it up, or either you can in this way. Okay, but obviously we are going to take from the air medium. So any particular incident angle which is going to be more than this particular critical angle, this theta 1 here, this theta 1 is going to be more than theta c. So in this particular scenario, the light is going to be trapped. Okay, the light ray is going to be trapped, and that is going to be coming back into the same medium. So that particular phenomenon is known as TIR in general. Application are more important. The same thing we are going to learn a lot of time. Okay, we already know this thing, right? So the formula for the TIR is nothing as such, N1 by N2, same, sine theta 1 divided by sine theta 2, sine I by sine R, where theta 1 is the angle of incidence, theta 2 is the angle of refraction, N1 is the denser medium, N2 is the rarer medium. But this theta 1 is always and always greater than theta c, and theta c is critical angle. So for critical angle, we have formula. As we know, sine I upon sine R is going to be N. You can say that, where N is nothing but C by V, right? Is this clear? Or you can write it down N21, that is N1 by N2 in this way. But what is a critical angle? Critical angle, that particular angle, angle of incidence is going to be angle of critical angle when angle of refraction is going to be 90 degree. So the moment I can do this, the moment I can do this particular thing, then simply sine C, or you can say sine theta C, is nothing but N21 or N1 divided by N2. So simply we can find theta C for any particular medium also. Theta C is nothing but critical angle, which is sine inverse simply nu, or for two specific medium other than air or other than vacuum, sine inverse N1 by N2. Is this clear, everyone? Okay, this thing is simple, right? So I think and I hope you understand this. Clear, everyone? This one, good. So critical angle, see, I already explained a slide ago, and then I just revised it on the written format. You guys get to know. So critical angle is defined as the largest angle of incidence for which refraction of light inside the medium still can be possible. Therefore, the angle of incidence when the angle of refraction is going to be 90 degree, and the ray which is refracting to total internal reflection is called critical angle. Mathematically, theta c sine inverse n2 by n1, where theta c is critical angle, n1 is Lancer medium, n2 is radial medium. Wait a minute, beta. This is important. I need to take this call. Just hello. Yeah. So that is all we, I mean that this particular thing already I let you know I discussed. So now TIR example, or you can say real life examples of TIR. So cladding core, what it is? It is a device known as core cladding optical fiber. Okay, optical fiber is a particular device in which we are going to use, in which we are going to see TIR, or in which we are going to use the concept of TIR. In this diamond also we are going to see, or in Mirage. What is everything happening here? So as we as we already know, TIR, total internal refraction, is a process whenever any particular light ray is going to come from incident to the you can say denser to the rarer. So this is in general what happening here. This is a kind of a optical fiber. What is the optical fiber in general? In this way you have a something look alike light. Okay, and this is an entrance. Obviously if it is a fiber, it is look like a wire. So first time light is going to be entered, and then inside there is a cladding and inner core. So cladding and inner core made in this particular sense. So the moment light is going to be enter from this particular one source, okay, from this particular not this color even here, from this particular one source, so it is going to trap inside it, and the trapping is going to be done on the process of TIR. So TIR at the boundaries of optical fiber to trap that particular light. Why we are necessary to trap? Why we are trapping this particular light? To make sure to transmit that particular light signal throughout large distances without any particular loss of communication. The optic fibers which you are guys using in your Wi-Fi, okay, your Wi-Fi serviceman or any particular provider tells you, bhaiya, I mean tells you in that way, sir and ma'am, please update your Wi-Fi from the normal wire to the optical fiber wire, or you can say fiber wire. So what it is, even in any particular you can say storm or rain or in any particular scenario, the internet connectivity signal is not going to be loose, and that even that particular thread is look alike as a hair of yours or some hair in simple sense. Okay, so there are so many small threads, white color threads. If you are interested more enough, so try to plug that particular, try to scratch that particular wire. So inside there is a cladding and core, a fine, very fine color, white color, like look like this, and these are basically optical fiber. Okay, so in optical fiber we are we are using this particular concept of TIR. Now in the same sense, whenever any particular light ray is going to be inside it in it, so that is going to trap, and due to this trapping, the any particular diamond is going to sparkle, because the refraction is going to be so many phases in so many edges, and these edges is going to sparkle and give you the sparkle. Okay, so that is the another example. So the very one of the famous and now latestly used optical fiber, then diamond, and then the third one is Mirage. Mirage we already given you guys in a great detail in class 10. So what is a Mirage? In desert, or in you can say in hot areas, in the month of India specifically, I am saying in the north side or in any particular side in the month of May, June and July. So you guys, if you are traveling on any particular double decker bus or on a train, so you see that far away there is a lake, or far away there is a source of water or a pond look like. Okay, so that is due to the heavy heat wave, the near earth surface, or you can say that towards the earth surface there, which is going to be hot, and above surface is going to be cool. So the cool surface is a denser and the hot surface is behaving like a rarer medium. And the ray of light is coming from the towards the surface which is a rarer medium, or I'm saying reverse. Okay, the ray of light which we are going to see is going to go from cooler medium to the hotter medium, denser medium to the rarer medium. So you see an effect which is known as a mirage. Okay, in this way. So as you can say, cool air, and that is your denser, and hot surface, that is going to be warmer air, is a rarer medium. So from cool air to the denser thing, it is going to be, so a reverse image we look alike, or a pond, or a water surface, or a water in general, and that particular, I used to see water on a highway, sir. That is the thing. Everyone used to see that particular small highway, or you can say shiny surface that look like a water. That is basically mirage. Okay. So one by one, the application like optical fiber is given, then mirage thing is given, and then that is important. So that is in general just total, you can say in a great detail explanation. So let's look at it, right? What it is in general. Because of the angle generated by the incoming beam is higher than the critical angle. As you can see, the angle, incidence angle, is going to be higher than the critical angle. As simple, this theta is going to be critical than higher critical angle. Total internal reflection occurs when it strikes the cladding. Optical fibers have revolutionized the speed with which the signals are carried across cities, nations, and continents, making telecommunication one of the quickest form of information or transportation. Endoscope is also used in optical fiber. Endoscope is a treatment in which a simple wire containing a small camera is going to put inside the human body. Okay, and then we are going to find the cancer tissue or any particular tissue which is going to be not properly working, or any particular cause which is going to harm the human body. Clear? So that is endoscopy. Then moving ahead, mirage, everyone know, it is an optical illusion that causes the water layer to appear at short distances in the desert or on the road. Total internal reflections which happens as a result of atmospheric refraction is an example of mirage. So that is the easiest thing, and we already know. They see the ears. Okay. Yeah. And that is important. Now that is going to be more important because in next lecture we are going to do the great detail study of prism. But in prism, TRIR is going to be also, we can see that in three cases, if any particular light source is passing in this way, there are three cases. So first, second, and third. Okay, if you put if we put this particular phase 90-degree angle coming to the light rays, or you can say 45 angle coming to the light rays, or in this particular angle. So prism is designed to bend light by 90 degree. In this way, it is going to bend the light ray 90-degree angle, as we can see coming in this way. You can see the light ray is coming in this way, and the refracted light is 90 degree to the initial incident. Here you can see that is going to be bent two times. First in this way 90 degree, and then again 90 degree. So in this way we can get 180-degree deviation or 180-degree rotation of incident light. So to rotate light according to our ways, either 90-degree, either 180-degree, or either in this way we can or 45-degree. So we can use this terminology of TIR. Prism is designed to bend light by 90 degree or 180 degree. Make use of TIR, total internal reflection. Such a prism is also used to invert images. What we are doing basically, if this is an image in this way, or you can say this is your object, so image is going to be in this way, or here it is. So basically we are inverting the images, nothing more we are doing. In the first two cases, the critical angle IC for the material of the prism must be less than 45 degree, because the angle of incidence is 45 degree. So we are making because we know theta c is nothing but sine inverse air to this, so directly n2 by n1, n2 is n and n1 is 1, so I can write directly n. Clear now? So we choose refractive index in this way, so the theta c is lesser than the 45 degree, and when the theta c, which is critical angle, lesser than the 45 degree, so we generally make use of this prism to rotate this particular kind of rays or images or any particular. Clear everyone? So we see from the table 9.1. This is 9.1 table is there. Okay, don't focus on this. Is this clear, beta? See, this is maybe taking from any particular textbook, so that particular thing which is not given here, not neither necessary. So application of TIR, optical fiber, an instrument in the telephone system. So optical fibers use total internal reflections. Optical fibers use total internal reflection. An optical fiber is made up of an inner core made up of a glass with a high refractive index and an outer plating made up of a glass with a lower refractive index. Okay, an instrument made up of a fiber optic wire is called an endoscope. Doctors used to view the interior of the human body, including the stomach and duodenum. Duodenum may be the eardrum, right, Vishwanath? And in the telephone system, fiber optics cables have now replaced copper cables in the telecommunications. Multiple signals can be transmitted quickly across the fiber bundles using laser generated light burst. Okay, and that is basically fiber, optical fiber. Do that. See, in today's date, yeah. So theory part we are done because a little bit pace. I do that deliberately because in today's class assessment, if I'm not wrong, you are guys going to get at least 10 questions. Okay, let me see. J2. 1, 2, 2. 6 only. I think that is going to be more than 6. Internal, okay. In the next class, I think it is going to be. Cool. Okay, do this. I'm not going to tell you about anything related to this. That is very easy. If the critical angle for a TIR, for total internal reflection, from a medium to a vacuum is 45 degree, then determine the velocity of light in the medium. Very easy. Critical angle is given and you need to find the light. How you can find the velocity of light in any particular medium? Just finding with the, just find that particular refractive index. And when you get refractive index n, then that is very easy, C by D. Clear? And theta c is sine inverse n. Do that. D option. Okay, let me check. Even I don't know. Beta D is not correct. Three divided by 1.414. Wait. 3 divided by 1.414. How can it be 2.12? Let me check it. How much you get this? Yeah, I think D is going to be correct. But just a minute. What I think. That is 3 divided by 1.414. Wow, then you are wrong. B, exactly. B is going to be then A. Beta, obviously. C. I am just checking out. That is the answer. Very easy, as we know. Given that the critical angle for TIR, theta C is 45 degree, the refractive index of the air medium is 1, n equals to, simply because we know that sine theta C equals to what? That is going to be n. Okay, for medium. Medium 2 is any particular medium, na? So n is going to be 1 upon sine theta C. I think I write a slide 1 by n. 1 by n is going to be the correct, not n. Okay, then everything you know, just put it down into the values and you get the correct answer. So the correct answer is B. This one, the same thing, n1 is given, made up of an optical fiber, is surrounded by the glass, refractive index n2 you need to find, and the critical angle is given. Do that. Are you solving beta, anyone, everyone? Got it, got it, got it. Okay, yes. The correct answer is already we know, but it should tell us, and that is the thing. Again, same thing, sine theta C is n2 by n1. Okay, so then you know everything. If this is the thing, theta is given, theta C is sine inverse this. Theta C is, you know guys, n2 you need to find. So simply n2 is sine theta C into n1. Exactly, the D is the correct answer. Two students get it done. Okay, so given theta is 50 degree, n1 is this, sine theta is this, 30 degree is going to be there. Wait, yeah. Okay, good. So in this way, in this particular class, what we already done, laws of refraction of light, What is refractive index? Snell's law, lateral shift, real depth and apparent depth, TIR, critical angle, and total internal reflection in nature and its technological application. So that much we already learned this in this class. Theory wise we are done.